So this is problem 5.27 in AOPS Introduction to Number Theory. How many of the positive divisors of 14,400 themselves have exactly 8 positive divisors? So we firstly factorize out 14,400, which is equal to 12 squared times 10 squared. So that's equal to 2 to the power of 4 times 3 squared times 2 squared times 5 squared. So we just combine the 2 to the power of 4 and 2 squared. We have 2 to the power of 6 times 2 to the power of 6 times 3 squared times 5 squared. So this is our factorization for 14,400. We want to know how many numbers which are divisors of this factorization here has exactly 8 positive divisors. So let's just call every divisor here D. So we can abstract this, we can make this more abstract. So we have 2 to the power of A times 3 to the power of B times 5 to the power of C. So we know that A has to be in the range of 0 and 6. B is in the range of 0 and 2. So B is in the range of 0 and 2. And we know that C is also in the range of 0 and 2. So basically right now, we have our 3 ranges, and we also want to consider in what cases this TD, we use this to denote the number of positive divisors for D is equal to 8. So when is TD equal to 8? So we know that, so we want TD to be equals to 8. So A plus 1 times B plus 1 times C plus 1 is equal to TD. So we want this product here to be 8. We know that A plus 1, B plus 1, and C plus 1 are all integers, since A, B, and C are all integers, and they're positive because A, B, and C are at least 0. So we can just factorize A as integers. So 8 can be written as 8, or 2 times 4, or 2 times 2 times 2. So we have 3 ways of factorizing 8, disregarding order. So we want to just make sure that this fits the range. So for our first ordering, we know, so for 8, we know that if we have D and then we have 2 to the power of 8. This actually works as an integer. However, A has to be in between 0 and 6. It can't be 8. So D can't be 2 to the power of 8. And same for B and C. When B or C are 8, they're out of the range of being at most 2. So 8 doesn't work. So we just try 2 times 4. So let's just say we have 2 to the power of 2 times 3 to the power of 4. In this case, A is 2 and B is 4. A is in the range between 0 and 6. However, B is over its maximum. Its maximum is 2, and right now it's 4. So that doesn't work. The same thing so that's the same reason this doesn't work for having 2 to the power of 4 and 5 to the power of 4. It's also out of range for C. So the only way you can do this 2 times 4 factorization is when we have 2 to the power of 4 times 3 to the power of 2, or we can have 2 to the power of 4 times 5 to the power of 2. In this case, A is equal to 4, and that is between 0 and 6. B or C is equal to 2, which is in range. So right now we have two divisors of 14,400, which have exactly 8 positive divisors. We also want to try out 2 times 2 times 2. So if we try out 2 times 2 times 2, we get the fact we can have 2. Wait, so this is 3 1 3 1 because we know that wait, sorry, this is 3, 1, 3, 1 because we know that A plus, so 4 is A plus 1, not A. So when A plus 1 is 4, A is 3. When B plus 1 is 2, B is 1. When C plus 1 is 2, C is 1. Okay, sorry, my bad. Okay, so now we try out 2 times 2 times 2. And we know that this fits the range of A, B, and C, because 2 minus 1 is in the range of 0 between 0 and 6, 0 and 2, and also 0 and 2. So we have another factorization, which is 2 to the power of 1 times 3 to the power of 1 times 5 to the power of 1. So this also fits in the range, and it's an integer, and it just fits the requirements. So we have 3 factorizations. So we have 3 divisors of 14,400, which have exactly 8 positive divisors. So our answer is just 3. So here, just beware that these values here refer to A plus 1, B plus 1, and C plus 1, not A, B, and C themselves. So thanks for watching.